Welcome to Maths for All. I'm Aisling Flynn. This is Calculus 1.2 Differentiation. So now we're going to look at some linear functions. To differentiate a function called y, or perhaps f of x if you're using function notation, means to find its slope. The result is called the derivative dy dx or f dash of x. So let's start with this green line, and this is the line y equals to 2x minus 4. And we've learned to find dy dx means to find its slope. Okay, and to find its slope we can simply do rise over run. So choosing 2 points that cross grid lines on the green line, I'm going to mark out my run there, which is 2 units from 2 to 4, and my rise is from 0 up to 4, so 4 units. So my slope will be 4 over 2, and so I can say that dy dx equals to 2. 4 divided by 2. Now let's just mark that and compare it to the original line. We'll do another one here, this time using function notation. Alright, so this purple line, you can see it's falling, and we'll look for 2 convenient points. I think this one here is 5. Alright, and let's see, where will we choose? Let's choose this one here. Okay, I think that's minus 1. Okay, so we're falling here down, so our rise is actually negative. So again, we're looking for a slope, which is rise over run. So we are falling from positive 5 to negative 1, which is a fall of 6. And there we are running from 0 over to 2, so our run is 2. And so we get the slope of minus 6 divided by 2. My f dash of x, my derivative, equals to minus 3. Okay. Now just take a minute to study the results for slope and look at your original functions. And where do you see the slope? It is beside the x value, isn't it? Now, so let's stick with straight lines for now, but here we're going to look at vertical and horizontal lines. So here's my graph. We have 4 different colored lines here. Let's first look at the horizontal lines. So the first horizontal line has an equation y equals 3. So which one is that? Well, let's look at the y-axis, which is here. Okay, and y equals 3. There's 3 on the y-axis here. And so what we're doing is we're describing this purple horizontal line for which every point along the line has a y value equals to 3. Okay, so y equals 3. So what is its slope? Remember that slope equals rise over run. So as you run from left to right, by how much does the purple line rise? And you can see that the answer is 0. It stays flat. It doesn't rise, it doesn't fall. So dy dx equals to 0. The slope is 0. The same is true for the next horizontal line. That one is described as y equals minus 1. So look for minus 1 on the y-axis. It's down here. Alright, so that describes the green line. Okay, and as before, dy dx equals 0, and that's true for every horizontal line, the purple and the green one there. Okay, what about vertical lines? Okay, so vertical lines are described by their x values. X equals 1 Okay, so on our x-axis here, we find the value of 1 here. And so this blue line here, every single point along the blue line has an x value equal to 1. And that's why it's called x equals 1. So when it comes to rise over run, okay, what is the rise? So you can see that blue line is rising, 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 straight up in the air, or falling straight down. I don't think we can define it because it goes on and on forever and ever. Okay, it's infinite, so that's one reason slope is going to be a problem here. Instead of rise, we'll have, let's call it infinity, which cannot be measured. Okay, and what about the run? It doesn't go left and right, so the run is 0. And in maths, that is a big no-no. You cannot divide by 0. It is undefined. So we say slope is undefined. We can't say what it is. Okay, the next vertical line is described as x equals minus 4. That describes the red line. So what do we take from that? That horizontal lines have slope 0 and vertical lines we cannot define. So what about quadratic functions? So the graph here shows a quadratic function, probably the simplest one, y equals x squared. So what is dy dx for a quadratic function? And it is the slope, okay? But look, let's choose a point to the left of the minimum point, which we find here at 0. X is 0. It's minimum at x equals 0. Okay. What is the slope, let's say, at this point here when x is minus 1? Well, to do that, we would be looking at perhaps a tangent. Well, that's not a tangent. Okay. What is the slope of it? Now, we can guess there. All right, but in a moment we're going to mathematically find it. What can we say for now? That it is a negative slope. What can we say about the slope at the minimum when x is 0? Well, we can say that one for sure because the tangent will be exactly horizontal, and we can say that the slope is 0. And let's move to the right. Let's go for x equals 1. The slope here, we won't define it right now, but we do know that it will be positive. Okay, so like I said, we'll do this mathematically shortly, and we'll reinforce these ideas. What can we say for sure from this one? We can say that dy dx equals 0 at x equals 0, so that describes the minimum. The rest we can't go there just yet. So now we're going to look at the mathematical operation of it. So how do you get dy dx? And we use this first rule of differentiation. Alright, it says that if y equals x to some power n, where n is natural number, then you can get your derivative dy dx equal to multiply by the n, so that's the old power, in front of your x, and then your new power will be n minus 1 or 1 less. Okay, so what I like to say is you multiply by the old power and you reduce the old power by 1 to get your new power. Okay, so let's have a look at what that is and what it means, okay, by doing an example. So let's start with our y equals x squared curve and apply the rule above. Okay, so my dy dx will be equal to, I have to multiply by the power in front, so 2 comes in front, then I have x, and then I have to reduce my power of 2 that I started with by 1. So what I'm going to end up with is 2x to the power of 1. So the 2 minus 1 give me that. And we normally just write that as 2x. Okay, so the slope is 2 times x. Now what does that mean? It's interesting because x takes a part of the slope. So it means that depending on where you go on your x-axis, which is what we saw on the previous slide, your slope will change with it. So for example, at x equals minus 1, okay, remember our tangent here, then my slope, dy dx, will be equal to 2 times the x, so 2 times minus 1. We get a slope of minus 2 on that side. Okay, at our minimum point, my dy dx will be equal to 2 times 0, which was the x value, so 0 is my slope, that's correct. And if we go to the right when x is 1, my dy dx will be equal to 2 times 1, which is positive 2, so we get a slope of plus 2 at that point. And indeed you can do the same for every point on the purple curve if you know its x value. Another example using rule 1. So y equals x to the power of 5. If that's what you're given, to get your dy dx, you multiply by the 5 in front. Then you have x, and then you have 5 minus 1 will give you the new power. So we'll get 5x to the power of 4. And you get very, very quick at this as you practice it. Next example is y equals x to the power of 10. dy dx will be equal to 10 times x to the power of 10 minus 1, which is 10 times x to the power of 9. And lastly, we have y equals 2x minus 5. So my dy dx will be, okay, so 2x minus 5, that's 2x to the power of 1. If it helps, you can write that 1 in as a power. So we're going to multiply the 2, or 1 in front, multiply by 2, multiply by x, and reduce the power 1 minus 1, which of course is 1 times 2 times x to the power of 0. Now what's anything to the power of 0? It's 1. So I get 1 times 2 times 1, which is just 2. Okay. What about the 5? Well, we saw when we did horizontal lines that a constant gives slope 0, doesn't affect it. Okay. And so we get, for what is a linear function here, okay, if you think back to the very start, a straight line just gives one single slope. We got to answer 2, and you see that the slope occurs there, whatever was beside the x. Now, rule 2 of differentiation, and we've already discussed this in detail actually. It says that when y equals a, where a is a constant, then dy dx equals to 0. So what they're describing here are the perfectly horizontal lines we discussed earlier. So when y equals 3, or when y equals 1, immediately we can say that dy dx equals 0. The slope is 0. The third rule of differentiation, rule 3, is similar to the first one, but it has a constant in front of the x. If y equals ax to the power of n, where a is any constant and n is a natural number, then dy dx equals an x to the power of n minus 1. So we'll see that in an example. Okay, so this time we have y equals 3x squared. So there's an extra constant in front of the x squared. Okay, we have an extra constant here. So let's differentiate. Dy dx equals, all right, so same as before, we'll be using our power to multiply in front. Okay, so following the format of the rule above, our a is 3, we'll have 3 times 2 times x, and then make that x larger, and then we will reduce our power by 1, so it'll be 2 minus 1. And what we get is 6x to the power of 1, which is just 6x. Okay, let's look at another example. 7x cubed. So dy dx will be equal to, so we'll have 7 multiplied by the power 3 multiplied by the x, but reduce the power by 1. And so what we'll get is 7 3s are 21, and x, where the power has been reduced to 2. So 21x squared. Next one. Again, if it helps, you don't see a power, write in a power of 1. My dy dx will be equal to 5 times 1 is the power times x, the power of 1 minus 1. Okay, so we're going to get 5 times x to the power of 0, and anything to the power of 0 is just 1, so the answer is just 5. Okay, and as you practice this, you write down, you don't go through this procedure each time. You get good at it and you're just able to write down the result. And last example for this slide, dy dx equals, so we'll have our 6 times the power 4 times our x, and reduce the power by 1, 4 minus 1, and 6 4s are 24, and we'll have x to the power of 3, so 24x cubed. Now here's a summary of the 3 rules on one slide. Now, differentiating a polynomial, you may have to use all 3 of those rules. Okay, a polynomial is a mathematical expression that joins many terms together. For example, here we've got the equation of a quadratic curve. Y equals x squared plus 9x plus 12, and we have to differentiate this. So we do each part individually and use whichever rule applies. Okay, so dy dx here will be equal to, so first we're going to take the x squared, so multiply by the power in front, 2 times x, and reduce the power by 1, so 2 by minus 1, plus the next one, we have 9x to the power of 1. Okay, so it will be 9 times 1 times x, and reduce the power by 1 is 1 minus 1, plus, now the next one, there's no x term there, this is a constant, so we treat this as you would the perfectly horizontal line. So to differentiate a constant, you just get 0. Okay, now let's tidy that up. Your dy dx will be equal to 2x, so it's x to the power of 1 plus 9 by x to the power of 0, which is just 9. So 2x plus 9. Okay, another example. So here we've got x cubed, x squared, an x term and a constant term. So dy dx equals to, so we'll have 3 times 3. Now we're going to try to speed things up a bit. Reduce the power by 1 means 3 drops to 2. Plus, we're going to have 2 times 2 for the second part, and reduce the power on the x by 1 brings me to 1. Now, minus, we have our x to the power of 1 here, so I'm on the third term here. So it'll be 1 times x to the power of 1 minus 1, which is 0, and that will become nothing. And at the end we have plus 1, which is a constant, and the derivative of that is 0. So my dy dx will be 3 times 3 is 9, so we get 9x squared plus 2 2's are 4 times x minus 1, and then the 0 is gone. So look at that. The derivative of the cubic function is quadratic x squared. If you go back up to the first example, the derivative of a quadratic function is a linear one, x to the power of 1. Okay, now one more example on this slide. And I chose this one because there's a fraction in it, but the same rules apply. So dy dx, or actually in this case it's dy dt. Okay, so it's how is y changing with your variable t. Okay, so the letters can change, of course. Okay, so let's change that up for a dy dt. So we have our third multiplied by the power comes in front, 2 times t to the power of 2 drops to 1. Okay, plus. And then we have 7 times 1 times t to the power of 0, and then minus for the 5 we get a derivative of 0. So what do we get for a finish? We get 2 over 3 times t plus 7. Remember that anything to the power of 0 is 1. Now it's time to put those things into practice with your quiz and your written exercises.